So we already know about user authentication, proving of identity in order to gain access to resources. But what about network authentication protocols? These are implementations of how users might be authenticated. So as an example, we've got some older protocols like Password Authentication Protocol. This is often just called PAP, P-A-P. This is one of those old legacy protocols that you should never use. And the reason is because it sends credentials over the network in clear text. Clear text transmissions means that you can use any freely available tool, like the Linux TCP dump command, or maybe the Wireshark network analyzer tool. You can capture those transmissions and without any challenge, there's the username and password. So we shouldn't be using Password Authentication Protocol. Then we've got other network authentication protocols like Microsoft Challenge Handshake Authentication Protocol, called MS-CHAP. Now there are various versions of that like MS-CHAP v2. Now if we take a look at the packet flow with MS-CHAP v2, what happens is we have a client that requests authentication from a server. Now the way that really feels in the real world is a user is signing in the morning to an app or perhaps into a legacy device, and they're entering in their credentials. So what happens is the server sends a challenge to the client. Then the client responds to that challenge, which is really prove your credentials. What happens is we get a hash of the user password. Think back to chapter 2 when Mike was talking about crypto and hashing. So we have a hash of the password that is then transmitted over the network to the server. The server will try then to compute that hash, compare the hash. If you know the hash of a password, that means you have to have known the original password once it's fed through a hashing algorithm. And so this way, we can authenticate over the network without actually transmitting the password at any point in time. All that's being transmitted is the hash. In Microsoft environments, you'll be familiar with New Technology LAN Manager, otherwise called NTLM. This is a network authentication protocol that actually supersedes the older LAN protocol, LAN Manager. And what you'll find is NTLM is used on work group computers. More specifically these days, NTLM version 2. What a workgroup computer is a standalone computer that's not joined to a central Active Directory domain, so it's managed individually on its own. So password hashes with NTLM are not salted. Again, back to Mike's crypto chapter, when you salt a password, you are adding some extra random information to make it more difficult to crack. Unsalted passwords are easy to crack, in seconds in most cases. Salted, not quite the same deal, much more complex to crack. So NTLM version 2 uses salting for those password hashes, so they're very difficult to crack. Now for the exam, if you get a question somehow testing what type of network authentication protocol is used in a Windows workgroup environment, so not Active Directory, NTLM v2 is what is used in that environment. But to take that a step further, what if I've got an Active Directory environment? What's used for that in terms of network authentication? The Kerberos protocol is used in that case. Well, we have various components working together. These components of Kerberos include the Kerberos Key Distribution Center, the KDC, the Authentication Service, the AS, the Ticket Granting Service, the TGS, and the Ticket Granting Ticket, the TGT. Those are just terms. What does it mean? What it means is that when you successfully authenticate using the Kerberos Authentication Protocol, which is used by Active Directory, once you successfully authenticate, you are granted a ticket from the Ticket Granting Service. And that ticket is what you present when you try to access resources in the Active Directory domain. And if you should have access to that resource, you're in without signing in again. It's kind of like going to a child's fair, going to the Ferris wheel and all that stuff, and buying tickets that you then use when you want to go on rides at the fair, at the amusement park. Same kind of idea with Kerberos. So Kerberos is used with Active Directory. NTLM v2 is used for workgroup computers. The Extensible Authentication Protocol, or EAP, that's spelled EAP, is a standardized framework. You're going to see this used everywhere in Windows environments, in unique VPN environments. What it allows is for more options for authenticating, such as authenticating using PKI certificates, or authenticating using a smart card. So these are items that you must have in addition to something you would know like a username. And often, EAP uses TLS as a transport mechanism. TLS is transport layer security. It means that we have encrypted secured network communications when authentication occurs. It's not in clear text. And this applies, EAP applies to both wired network authentication and also wireless network authentication. You can't talk about network authentication without talking about IEEE 802.1x. Now don't confuse that with 802.11. That's for Wi-Fi protocols. 802.1x is a port-based network access control protocol. It controls access to the network in the first place. Think about it. One of the first lines of defenses that you have is limiting who can get on your network in the first place. Because if a malicious actor gets on your network, then they can start scanning and looking for vulnerabilities and potentially compromise things. We want to limit network access. Now, one way that we do that is with IEEE 802.1x compliant network edge point devices that hand off authentication requests elsewhere to a centralized server called a radius server. So this applies to wired and wireless networks, and the devices that we're talking about that can authenticate people to the network include things like network Ethernet switches, or it could be a router, whether it's wired or wireless. It could be a VPN concentrator. These type of devices are at the network's edge. And so when we get a request to authenticate, they're the ones that deal with that and can hand it off to a centralized authentication server. Now let's talk about that centralized server for a second. That's a radius server. Radius, in case you are interested, stands for Remote Access Dial-In User Service. Yeah, it's outdated. We're not dialing into anything, but it stems from way back in the day. So we're talking about just having a centralized authentication server. Now, terminology is important. So we know that a radius server is an authentication server. It could be an Active Directory domain controller. But what about a radius client? At first thought, you might say, well, that's the device trying to connect to the network. It's actually not. Because the radius client is the network edge point device, whether it's a network switch or a VPN appliance or a wireless router, whatever's on the network's edge, that is actually the radius client. So then what do we call the actual user, let's say with the smartphone that's trying to connect to a network? We call them the radius supplicant. So terminology is always important, and it could be easy points on the Security Plus exam if you're somehow tested on your knowledge of those terms. Now there are variations on radius like TACACS, TACACS Plus, and XTACACS. These are variations of how the radius centralized authentication protocol works, but they all fall under the realm of radius. So in our diagram, we see we have a supplicant shown over on the left of our picture. This, in this example, is a smartphone. Now that user might be using a smartphone to connect to a Wi-Fi network. So if the wireless router is IEEE 802.1x compliant, then instead of the wireless router actually doing the authentication, it's been configured to hand that off to a centralized authentication server, the radius server, elsewhere. So this means that we don't have to worry about authentication being handled by the edge point device. It's going to have limited memory and it can only handle so many details for user account credentials. Not only that, do you really want an edge point device storing credentials? It's on the edge of the network. If it gets compromised, so are those credentials. We don't want that. So we've seen then that there are some network authentication protocols that can be used and some that should not be used in order to harden our network environment.